Print it out for you. All right. So polar equations, what are they? So they offer a different mathematical perspective on graphing. So far, you've been representing graphs of equations as collections of points, x, y, on the coordinate system. X and y have always represented distances from the coordinate axis to the point x, y. So like an x coordinate is just how far away a point is from the y axis, and a y coordinate is just how far away a point is from the x axis, all right? So we have a new system called the polar coordinate system, where the origin is now called the pole. The positive x-axis is now called the polar axis, and each point can be assigned polar coordinates r comma theta. So instead of x comma y, we got r, which you probably would guess means like radius, and that's true. It's like the distance that the point is from the pole or the origin. And theta refers to like the angle of rotation from the positive x-axis. All right, so theta is now the independent variable. Theta is the angle rotated from the positive x-axis to the polar axis. R is the distance from the origin, the pole. So the polar axis exists in the same plane as the xy coordinate plane. So today we're gonna learn how to graph polar coordinates and then convert from polar coordinates to xy, rectangular coordinates, and vice versa. So what that means is like you could overlap the x and y axis on here, and like any point could have like a x and y coordinate or a polar coordinate. All right. So we'll see that later. It's important to realize that this is not a new coordinate plane. Okay. So like what that means is like if I move like 1, 2, 3 units to the right and then like 1, 2, 3 units up, like that's still in x and y format, still like 3, 3. It's just we'll have a different representation on the polar axis. So that's why we're allowed to go back and forth. So we usually use a different type of graph paper for polar points and equations. Hence why I passed those out to you. And when you run out, just let me know. I'll give you new ones. So how do you plot polar coordinates? All right. So if you're given 2 points, r comma theta, first you rotate the angle. So you start on like the positive x-axis and you rotate counterclockwise. And then you walk out from the origin in the indicated direction. So that's important, direction. If after you rotate, all right, you're gonna move like away from the origin, like in a positive direction, if it's positive, or backwards would be the other direction. So I'll explain that for specific points. All right, so in rectangular coordinates, each point xy has a unique representation. All right, so what does that mean? Like the point 2, 5, there's no other point on the x and y axis that has the same location as 2, 5 with different coordinates, right? Like there's only 1, 2, 5, and there's only one -3, 4. All right, with polar coordinates, you can have 2 different polar coordinates that have the same exact location. All right, and that has to do with like coterminal angles, and we'll see an example of that. All right, so so let's take the point. So here's a specific example. All right, let's take a point 5, pi over 4. All right, so first, where would that be on the polar axes? All right, so first you start here and you rotate pi over 4. All right, so now we're along this line here. All right, so now since it's the theta is pi over 4 and r is 5, we're gonna move 5 in this direction. So we rotate pi over 4 and then move 1, 2, 3, 4, 5. All right, now if it was -5, then we just move behind. We'd move this way. All right, so that's where that point would be. You rotate pi over 4, 45 degrees, and then move away from the pole 5. All right, now that would be r comma theta. So r comma 2 pi plus theta, 2 pi plus pi over 4 would be 9 pi over 4. All right, so that is the same exact angle, and pi over 4, not same exact, but it's coterminal with pi over 4, 9 pi over 4. So 5 comma 9 pi over 4 would have the same location. You would rotate 9 pi over 4, which is, 360 degrees plus 45, and then move out 5. 1, 2, 3, 4, 5 units. All right. So that would also have that same location. All right. You could also do -5, comma, theta plus pi over 4. So that would be 5 pi over 4. All right, because -5 just means we're going to go in the other direction. So this point also has this location because we would start on the positive x-axis, move 5 pi over 4. So that's pi plus pi over 4. So here, all right, but instead of moving 5 towards that angle, we're going to move -5 away from that angle. All right, so these are just 3 of infinite, because you can always find coterminal angles, 3 different ways to express this same location on the polar graph. All right, so something to keep in mind when you're doing this. All right, if you get like 2 different points that have the same location, that doesn't necessarily mean doing something wrong. All right, and you can use these to find like other points. All right, and this works because it's coterminal, and this works because by going in the opposite direction, it's like adding pi. Like instead of going like 5 and then, or pi over 4 and then move in the positive direction, if you went pi more than that, you're still on this line, then just move in the negative direction, you end up in the same point. So it kind of is the same thing as like a coterminal angle. All right, so I'll do 2 of these, and then you guys, I'll give you a couple minutes to try the other ones on your own. So for A, all right, 4 comma pi over 6. First, we're going to work here, and we're going to move pi over 6 and then 4. So 1, 2, 3, 4. So it'd be like right around here. I'll try to zoom in a little more. You know what? I need to make turn the light off so you can see it better. Okay, it's not zooming in. Just know that I'm trying. It's just not zooming in. Up. All right. Yeah. There's no zoom in button. You gotta do this like weird finger motion on the mouse. All right, that's the best you're gonna get. So that's point A. All right, 7 comma 7 pi over 12. All right, so one thing you could do, because there's no like pi over 12 on here, all right, you could like convert this pi over 2 to like 6 pi over 12, and then 2 pi over 3. That, if we get a common denominator, multiply the top and the bottom by 4. I don't know why I crossed it out, but that would be 8 pi over 12. So 7 pi over 12 is going to be like right in between. All right, so we open up from the positive x-axis, 7 pi over 12, and then we move back 7, or away from the origin 7. So 1, 2, 3, 4, 5, 6, 7. All right, and that would be point B. So, I mean, I wouldn't do it. So now I want you to try C, D, E, F, and G on your own for a few minutes. And I wouldn't waste a graph per point. I would just put them all on one graph, just a word of advice. All right, so try C, D. And if you have questions, just let me know. I just want you to like think about it on your own before I just show you every single problem. All right, and D is a little different, but see if you can figure it out. But they're all polar points. Yes?
So for B,
yeah.
the x coordinate is like positive, so how come it's like the second positive?
So you mean like the 7 is positive?
Yeah.
So 7 just means like after you rotate, you move like towards. So imagine it like, sorry, people at home, it's hard to do this on the document. But imagine like, all right, this is like an arrow, right? Like where my pen is pointing. All right, so I'm pointing in that direction. So that's like the positive direction. So I'm moving 7 pi over 12. And now since it's positive 7, I'm going to move that way at 7. All right, if it was, so that's all that means, the 7, that you're moving 7 units away from the pole. That's the radius right here. All right, and 7 pi over 12 means you just rotate that many radius. Now, if this was a negative 7, then you would still rotate 7 pi over 12, but the -7 means now we're gonna move backwards 7. So imagine like you're always pointing like towards positive x-axis, you rotate, and then positive means you move in that direction, negative means you move backwards.
So can you put the like coordinate anywhere on the line then, with that like the arrow? So like for B, it's like towards like the end of like the circle, right?
Well, it's 7. It's exactly like 7 units away.
Okay.
Like I'm counting like the rings, like 1, 2, 3, 4, 5, 6, 7.
Okay.
Like the radius is 7. So that's why it's r comma theta. Like, so the next one, 6 comma 0, should just be 0 degrees. So just facing this way, but 6 units away. All right, problem. All right, and for the people at home, all I was doing on the board was like for B, I was describing, all right, let me write this for like using Zoom so I don't ruin the thing. So for B, you would rotate 7 pi over 12. Oh, I have an arrow tool, that's sick. All right, so now we rotated 7 pi over 12 and we're facing that way. So since it's a positive 7, we're gonna move like towards the arrow, like towards the B, where like we originally were facing like this way. So we rotated 7 pi over 12 and we moved towards the B. If it was a -7, then we move the other way along this line. Okay. I'll give you another minute. Probably can't even read that. Don't want to zoom in. Maybe if I try to zoom out, it'll zoom in. Oh, now it's just zooming out. Let's go. Oh my God. I guess that helps. It does help. All right, I'm gonna like more time strategies. All right, so let's talk about them, and you'll get plenty of practice later if you did run out of time. All right, so C. All right, so we're 0 degrees, so we're on the positive x-axis, like 0 degree angles, and we move 6 away. So that's where C would be. All right, now for D, I said D was a little different. All right, so you should always assume that this is in radians, all right, unless it specifically says otherwise. And this is honestly the first time I'm ever teaching polar coordinates, so I don't know, but I'm pretty sure we're never going to have to deal in degrees. But I don't know because I haven't looked that far ahead yet. So 5 comma 5 means, all right, we got to move 5 radians counterclockwise. So to understand where that would be, I converted it to degrees. So to go from radians to degrees, you multiply by 180 over pi, because usually radians are in terms of pi. So that's how I remember multiply by 180 over pi, because I want to divide out the pi, which is usually there. So I get 286. So I went 270 and just like a little more. All right, if you notice, like each quadrant is divided into 1, 2, 3, 4, 5, 6 parts. So 90 degrees divided into 6 parts would be 15 degrees. So if I went 270 and then 15 more degrees, like that would be somewhere like a little longer. So you go 5 radians and then 5 units out, and we're at point D there. All right, for E, so E's over here because we moved pi over 3, but instead of moving positive 3, we're moving negative 3. So we move backwards across this line. All right, and that's where E would be 3 units behind the pole. And then negative 2 pi over 3. So instead of rotating counterclockwise, we're going to rotate clockwise. So this right here would be negative 2 pi over 3. All right, and then we move 5 units out to F. All right, and then G, so 3 pi over 2. So we rotate counterclockwise, and then we move down 5.5, all right, to point G. And then point H is actually the same exact point, because instead of moving 270 or 3 pi over 2, we're moving 90. And wait a minute. So my bad. 90 would be here, this way. And then we move backwards 11 pi over 2. So G and H are the same point. Any questions? All right. Nice. So let's flip it over. Cool. All right, so this is what I was talking about before, about how like the X and Y axis it's not like a separate thing. Like the polar axis is sort of like on top of the X and Y axis. So any point could have like its polar form and its rectangular form. All right. So here's some important things that we need to know in order to go back and forth. All right. So recall that the cosine of theta is equal to X over R. All right. That was our definition, and from trig back in the day. And you can use this picture to help you understand that. Like if this is theta, all right, and for an angle in standard position, and you drop a perpendicular line down, all right, you create a right triangle where the adjacent leg is the X coordinate of this point, because you move X this way, and then up Y. So the opposite leg is the Y coordinate of this point. Then the hypotenuse is just R, because if you rotated this all the way around, it'd make a circle, and R would be the radius. So cosine is adjacent over hypotenuse, or X over R. All right, and then sine is opposite over hypotenuse, Y over R. So that means X is equal to R times the cosine of theta, and Y is equal to R times the sine of theta. All right, and then that should also remind you of like when we did parametrics graphing circles. Okay. Now R squared, you could say, is equal to X squared plus Y squared, because of the old Pythagorean theorem. All right, A squared plus B squared equals C squared. Well, this is a right triangle. X and Y, those coordinates are legs, and the R is the hypotenuse. All right, and then tangent is sine over cosine. So if you divide Y over R by X over R, the R's would cancel, and we get tangent is equal to Y over X. All right, so this is what we're going to use to convert from polar to rectangular and rectangular back to polar. All right, so definitely want to have this somewhere, especially if we take a quiz or on this stuff. Okay, so convert these polar coordinates to rectangular coordinates. All right, so going from polar to rectangular, you're going to straight up want to use these here. All right, so X is equal to R times the cosine of theta. All right, so R is 3 because it's a polar point, and theta is pi over 2. So X would equal 3 times pi over 2. So cosine of pi over 2. So that's going to be 0, because the cosine of 90 is 0, and 3 times 0 would be 0. And then Y would be 3 times the sine of pi over 2. All right, which would be 3. All right, now this would be a good time to take a word from our sponsor. And our sponsor today is that chart that you should have memorized a few months ago and probably forgot because we haven't done trig in a while. All right, so let's go through that real quick. So we got sine, cosine, tangent of theta. All right, so theta could be 0, pi over 6, 45, pi over 4, pi over 3, and pi over 2. All right, so you definitely want to refer to this at times. So remember, the way you could fill this out is the top row has a pattern. It goes root 0 over 2, root 1 over 2, root 2 over 2, root 3 over 2, root 4 over 2. I think that's fascinating because I don't understand why that pattern exists, but it does. It's pretty crazy. keeps me up at night. But anyway, so really killing it today with the jokes. All right, so this would be 0. This would be 1/2. Root 2 over 2, root 3 over 2, and then that's just 1. All right, so if you have that written down, if you don't have it committed to memory, then it'll save you some time. And then cosine and sine are coterminal angles. No, they're not. They're co-functions. So that means like the sine of an angle is going to equal the cosine of that complement. So like the cosine of 20 will equal the sine of 70 because they add up to 90. So that means for this table, the next row is just the top row in reverse because like 0 and 90 add up to 90 and 30 and 60 add up to 90 and 45 and 45 add up to 90. So we get 1, root 3 over 2, root 2 over 2, 1/2, and 0. And then tangent is sine over cosine. So for the bottom row, you just divide these. So 0 over 1 is 0. 1/2 over root 3 over 2 is 1 over root 3 because the over 2's cancel out. Root 2 over 2 over root 2 over 2 is just 1. Root 3 over 2 over 1/2 is root 3. 1 over 0 is undefined. All right. And 1 over root 3 rationalizes to root 3 over 3. All right. So there's our table. All right, and now back to our featured programming. So we got x is 0, y is 3. And I'll do this on Zoom so I don't run out of space writing. But just to show you how the polar and the actual x and y axis graph relate. So first, let's find like the polar version. So we would move. So to graph this in polar form, we would rotate 90 degrees. All right, so 90 degrees is pi over 2. And then we would move away like 1, 2, 3. So this right here would be that point, 3 comma pi over 2. All right, well, if you now look at this as an x and y axis, that's also the point 0 comma 3. So that's what I mean by like, the x and y axis still exists. It's just like another way to use it. So 0 comma 3 would be 0 left and right up 3. It's the same point. All right. So if you overlap an x and y axis and a polar axis, you know, when you convert from one to the other, they should be in the same exact location. All right. So yeah, so it's basically just plug and chug into these formulas. So like for this next one, all right, x is equal to r times the cosine of 2 pi over 3. So 2 pi over 3, all right, so you can also refer back to the first page here. 2 pi over 3 is also 120 degrees, which has a 60-degree reference angle. So the cosine of 2 pi over 3 is going to be 1/2, but it's going to be negative 1/2 because it's in quadrant 2 where cosine is negative. So another thing you might want to jot up here if you forgot was ASTC to remember where certain trig functions are positive. So quadrant 1, they're all positive. Quadrant 2, only sine is positive. Quadrant 3, only tangent's positive. And quadrant 4, only cosine's positive. All right, so then this means our x coordinate is going to be positive 1 because that's negative 2 times negative 1/2. All right, and then for y, all right, do the same thing. So negative 2 times the sine of 2 pi over 3. All right, so that's negative 2 times positive root 3 over 2 because quadrant 2 sine is positive and the reference angle is 60. All right, so we get negative root 3 for y. So our polar coordinate would be at 1 comma negative root 3. Okay. Any questions? All right, so that's the gist of it. I could do a couple more examples, but I'm basically just going to be plugging into that formula. I'm just trying to find one that looks the hardest. Let's do this one down here. So, and they're all kind of equal difficulty. So, all right, just one more polar to rectangular. All right, x is equal to r. So r is 8 root 2 times, All right, x goes with cosine. So the cosine of negative 3 pi over 4. All right, and then y would equal 8 times root 2 times the sine of negative 3 pi over 4. All right, and quite frankly, you could just use your calculator at this point. All right, just make sure that it's in radians because this is in radians. So, you should know how to do this without a calculator, but if you know how to, if you do a couple without a calculator and a couple with a calculator, I'm fine with that, just so you know how to do it both ways. But yeah, you would basically just type that in, make sure the calculator is in radians, and you would get 8 root 2 times, now another quick note on the calculator, like if it doesn't have a reference angle, like one of these, like 0, 30, 45, 60, or 90, or in radians, those angles, then you must use a calculator or a trig table, or else it's pretty impossible to do. All right, so 8 root 2 times the cosine of negative 3 pi over 4. All right, so negative 3 pi over 4 is going to have a reference angle of pi over 4. So that's going to be plus or minus root 2 over 2. All right, and then it's going to be negative root 2 over 2 because negative 3 pi over 4 would be like negative 135 degrees. And that's in quadrant 3 where cosine is negative. All right, and then same thing with sine. All right, sine is also negative in quadrant 3. And this is also a reference angle of pi over 4, which means they'll have an absolute value of root 2 over 2. All right, so then this comes out to be, so we multiply across, all right, this is going to be negative. And then 8 times root 2 is like 8 times 2. But then divided by 2 just gives us a negative 8. And then here, we get negative 8 times root 2 over 2. All right, that'll just cancel out, and we get negative 8. All right. And I think it's important to point out that, like, when you have something with a 45-degree reference angle, that's always going to occur with like a polar coordinate that has a reference angle of 45 degrees. Because if you think about it, if you ever move like 45 degrees, so like halfway in between the x and y axis, you would be like on a line that has a slope of 1. All right, so like if we moved negative 3 pi over 4 or negative 135 degrees this way, then we'd be on this line that pretty much goes through like every corner of the box, where if that slope is 1 and it goes to the origin, then like the x and y coordinates should always be either the same or opposite. So that's always going to happen for like something pi over 4. And if it's something that's coterminal with like an axis, like 0 degrees or pi over 2 or pi or 3 pi over 2, then one of the coordinates is going to be 0 because it falls on an axis. All right, so things you can think about. All right, and then last thing, converting polar. Oh wait, is there more stuff on the back? No, I'm so confused right now. Oh, I see, I have 2 different copies. All right, so now converting rectangular to polar. So, all right, first I want to do this just with like, without using any of the equations up here, all right? Just kind of using common sense and thinking it through. So you have like a visual to connect this to. And then I'll show you like the way you should do it every single time without fail. But this method might be hard in certain scenarios. But let's say we have the point 3, 3. So there's my y-axis, there's my x-axis. So the point is at 3, 3. So let me move. I'm going to go this way, 1, 2, 3, and then this way, 1, 2, 3. All right, so boom, there's my point, 3, 3. Now, if I was converting this to polar, all right, I'm going to use pi over 4 for my angle, because if it's on this like line here that goes to the point 3, 3, that slope is going to have a slope of 1 because you move like right 3 and then up 3. So that means this is an isosceles triangle, which means this is 45 degrees. All right, so for my polar, all right, I'm going to put pi over 4 here. And then r is just the distance that that point is from the origin. So that, if you know your special right triangle stuff, that's just going to be 3 pi over 2. And you could use this logic and trig to think about all of these. It's just there's formulas that you can use that makes your life a little easier because it requires less thinking. But I mean, that's it. There's your polar equation. R is how far away it is from the origin. So you find the distance. And then theta is just, all right, like what's the angle of this line in which the point lies on? All right, so now to do that same one with the formulas above, all right? So remember, we're looking for the polar coordinate. So r comma theta, and we have x and y. So to find r, you could just use this right here. R squared equals x squared plus y squared. And that's the Pythagorean Theorem, which is how I use 3 and 3 to find 3 root 2. So to find r, I could just do r squared equals 3 squared plus 3 squared. So we get r squared is equal to 18. So r squared is equal to root 18, which that's 9 times 2. And the square root of 9 is 3. So r is equal to 3 root 2. All right, so in my final answer, I know that the first coordinate is going to be 3 root 2. Now to find theta, since you know x and y, I mean, you could theoretically do like x equals r times the cosine of theta and plug in the x value and what we got for r. Or theoretically, you could plug in the y value and the r value that we have and solve for theta. But the easiest way, if you're given x and y, is to use tangent. All right, so we know that the tangent of theta is equal to y over x. So that would be 3 over 3. All right, so that means theta should have a reference angle of pi over 4. And since this is a coordinate in quadrant 1, I have to make sure that my angle theta is in quadrant 1. So pi over 4 is already in quadrant 1, so I could just use that. Or any angle coterminal to it would be fine. All right, so that's how you do that one. And then let's just do one more. So let's do this one, -10, 4, all right? So if it helps to like sketch a picture, all right, -10, so it's gonna be up here, whatever. So -10, 4 would be somewhere in quadrant 2. All right, it's important to know where the quadrant is. All right, so to find r is the distance at that point is from the origin or the pole. So you could do the Pythagorean theorem, all right? So to find r squared is equal to 4 squared plus -10 squared. All right, make sure you put that in parentheses because that should come out to be 100, not -100, because we're squaring that whole side length. So we get r squared is equal to 16 plus 100, which is 116. So we get the square root of 116, which that would be 4 times 30 is 120. So 4 times 29 would be 116. So r comes out to 2 root 29. All right, so we got r. And now for theta, we know that the tangent of theta is equal to y over x. So 4 over -10, which would be -2/5. Now, -2/5 is not one of these memorized values. Therefore, you must use a calculator. And so you would just do theta is equal to the tangent inverse of -2/5. All right, making sure the calc is in radians. And my calculator to pull that up would take like a minute. So I assume you all know how to type that in the calculator. If not, just ask and I'll happily show you. But if you type that in, I did this earlier, that comes out to 2.75 radians, which you don't, if you're doing it on the calculator in radians, you don't have to put it in terms of pi. You can just leave it like that. So we got theta, we got r, so we're good. We got our point, r comma theta, 2 root 29, comma 2.75. All right, and then there are other examples here. If you want to try them, I could show you the answers. But for now, I'll just give you the rest of the class to either finish these or you could skip them if you feel good. But they're here if you want extra practice. and start the homework. And if you have questions, just ask. And tomorrow I could share the answer key with you and you could check your work. But that's all the new stuff that we're going to learn today.